Welcome to 7.3 Adding and Subtracting Rational Expressions. Today we are going to go through the steps of addition and subtraction. One thing that's different from what we did with multiplication and division, now we have to actually find a common denominator in order to add and subtract. So we are going to have similar steps. We're going to first start by factoring. Then we are going to identify undefined values by setting our denominator not equal to 0. Then we have to find the least common denominator, and we'll have to go in and multiply if needed on either fraction to make it so that they both have a common denominator. Then we'll add or subtract the numerators. 5 and 6 are steps that we may have to do if possible. If I can factor, I should factor to see if anything is going to cancel out in my final solution. So let's go ahead and look at number 1. I have 3x minus 4 over x squared minus 1 minus 6x plus 1 over x squared minus 1. The first thing we're going to want to do is factor our denominators. So I have x plus 1, x minus 1, because this is a difference of perfect squares. X plus 1, x minus 1, because it's the same difference of perfect squares. Now I'm going to go in and I'm going to set my denominators not equal to 0, because I know that these two guys have the same exact denominator. So that's going to give me x cannot equal positive 1 and x cannot equal negative 1. Now that I have this, I'm going to go ahead and write my numerators over one common denominator. And this problem is nice because I already have my common denominator. So I have 3x minus 4 minus 6x plus 1. Remember that it's minus this entire statement, and we wrote that all over x plus 1, x minus 1. The reason why I really highlighted it by putting parentheses is because you have to be careful. This negative is going to distribute to the 6x and to the positive 1. So really, I have 3x minus 4 minus 6x minus 1 all over x plus 1, x minus 1. So I'm going to combine like terms, and that's going to give me negative 3x minus 5 over x plus 1, x minus 1. Now, yes, in my numerator, I could factor out a negative 1, but that's going to give me 3x plus 5, and I know nothing is going to cancel out with that. So it is okay to leave my numerator as is. I'm not going to go through the steps of factoring and simplifying because it's not going to get me anywhere. So let's go ahead and look at number 2. This time I have 2 over 3x plus 5 over 7x. Well, I can't do any factoring of my denominators, so I'm going to set them not equal to 0. And basically from both of them, it's going to tell me x cannot equal 0. And now I have to decide what's the common denominator for 3x and 7x. Well, they both have an x in common, so I don't need to do anything with that. And 3 and 7 are not the same, but they both multiply to be 21. So I need to multiply this first fraction top and bottom by 7, this fraction top and bottom by 3 to get a common denominator. So top and bottom by 7, top and bottom by 3, and that's going to give me 14 over 21x, because remember, multiplying fractions is numerator times numerator, denominator times denominator, and 15 over 21x. Now remember, anything you multiply the denominator by, you have to multiply the numerator by, because it's like multiplying by 1. So that's why I have 7 over 7 and 3 over 3. Now that I have a common denominator, I'm going to go ahead and I am going to combine my numerators. 14 plus 15 is going to give me 29 over the common denominator, 21x. And I can't have anything factored in my numerator, so I'm not going to go through those factor and simplify steps for this problem either. Okay, for number 3, I have m over 3m plus 6 minus 4m over m plus 2. And the first thing I'm going to do is factor. And I have a GCF in my first denominator, so that's going to give me 3m plus 2. And I can't factor anything with m plus 2. So I'm going to get my undefined values. And remember, when I have 3 not equal to 0, nothing is going to come from that. But m plus 2 not equal to 0 is going to give me m cannot equal negative 2, which is the same thing I get from my second denominator. Now I need to find my common denominator, and they both have m plus 2 in common. The only thing missing in my second fraction is this 3. So what I'm going to do is I'm going to multiply top and bottom by 3 over 3. 3 times 4m and 3 times m plus 2. Once I get that done, I get m minus 3 times 4m is 12m all over my common denominator, 3m plus 2. Now that I have that taken care of, all I have to do is simplify my numerator. M minus 12m is going to give me negative 11m over 3m plus 2. My one undefined value is m cannot equal negative 2. Now we're going to spice things up a little bit. So for number 4, I'm going to go ahead and get started with my factoring first. I need to factor both denominators, and that's going to give me x over x plus 2, x plus 3, minus 2 over, there should be a line there somewhere, 2 over x plus 2, x plus 2. We'll just draw it in for this one. Now, I need to create a common denominator, but before I do that, let's go ahead and write our undefined values. X cannot equal negative 2, x cannot equal negative 3. Remember, you do not have to write multiples of these in your final answer. Now to determine what I need to have a common denominator. Well, both of them currently have an x plus 2, and it looks like my first denominator has an x plus 3, and my second denominator has an x plus 2, another one. So both of them need something. The first fraction needs another x plus 2. The second fraction needs an x plus 3. So I'm going to multiply top and bottom, x plus 2 over x plus 2 for my first fraction, x plus 3 over x plus 3 for my second. Remember, you do not have to multiply out the denominator. Leave it in factored form. So now let's go ahead and multiply and rewrite our numerators together over a common denominator. So x plus 2 times x is going to give me x times x plus 2 minus my 2 times x plus 3 all over my common denominator, x plus 2, x plus 2, x plus 3. Now that I have all of this taken care of, I am going to start distributing it. X times x is x squared. X times 2 is 2x minus 2 times x minus 2 times 3. And that's going to give me my very long denominator. And then we start to simplify, write this easily. So I can see that plus 2x and minus 2x are going to cancel each other out, leaving me with my final answer of x squared minus 3. And remember, I can only factor this if this was a perfect square, but since it's just a 3, we leave it alone. My two undefined values are negative 2 and negative 3. Number 5, negative 3x over x squared minus 9 minus 4 over 6 minus 2x. Now before I start factoring, I do want to go in and take this denominator that's not written in an order that I'm used to and rewrite it as negative 2x plus 6. The reason why I like to do this, especially in these types of problems, is because it's going to make it easier for us to see how to make a common denominator. So let's get factoring. I have a difference of squares. This is becoming x plus 3, x minus 3. And now that I know I have x minus 3 as a factor, I can take out a GCF of negative 2 and get another x minus 3. Once I get my undefined values, x cannot equal plus minus 3, I'm going to start building that common denominator. X minus 3 and x minus 3 match. I have an x plus 3 in my first fraction and a negative 2 in my second. So I can kind of see what each piece is missing. This is going to need negative 2 over negative 2. This is going to need x plus 3 over x plus 3. So I'm going to give both of these fractions what they need. Top and bottom by negative 2, top and bottom by x plus 3. Going to distribute my multiplication and rewrite over a common denominator. Negative 2 times negative 3x minus 4 times x plus 3. Make sure that you are distributing not only the 4, but the negative as well. That's going to give me 6x minus 4x minus 12 all over my common denominator, negative 2x plus 3x minus 3. I'm going to combine like terms. 6x minus 4x is going to simplify to be 2x minus 12. And I'm going to see now I have 2, 12, and 2. All of those things have a common GCF. So I'm going to try to pull that out as best as I can. So I'm going to take from my numerator a GCF of negative 2. That's going to leave me with negative x plus 6. And now that I have that, I can go in and cancel out this negative 2 and this negative 2 because it's multiplication, multiplying by these parentheses. Therefore, they get to be canceled. Now, my final answer ends up being negative x plus 6 over x plus 3, x minus 3, where x cannot equal plus or minus 3. Okay, now we're going to shift gears a little bit and go back to dividing, but this time we're going to do it with complex fractions, which means it's a fraction where you have a numerator, denominator, or both are fractions themselves. Now, one thing to remember about dividing is we keep the first fraction, change it to multiplication, and flip the second fraction. A very simple example of a complex fraction is written out over here, 1 over 3 over 3 over x. My first suggestion is to always write it in a form that you are comfortable with. So I have 1 over 3 divided by, because remember, division is the same thing as this fraction bar, divided by 3 over x. So I don't necessarily have specific directions written out for this, but I'm going to give you a general idea of what we are going to do. First, we're going to rewrite. We're going to change it like we did this example problem into a form that we are comfortable with. And then, if necessary, we're going to add and subtract any fractions that need to be combined so that I have one fraction over another fraction, not 2 over 1 or 1 over 2, nothing crazy like that. Try to get it in a simplified form, one fraction over one fraction. Then we're going to do our keep, change, flip. We're going to figure out any undefined values, multiply, and simplify. So first thing I'm going to do for my problem number 6 is I'm going to rewrite. I'm going to rewrite this so that it looks like a form I am comfortable with. My numerator divided by the denominator. Going to make your life so much easier to think of it like this. The next thing I have to do is I need to add or subtract anything in my parentheses because I want one fraction divided by another fraction. So I'm going to combine 3 over x plus x over 2. Now, in order to do that, they need a common denominator. So to simplify things, I'm just going to add the multiples in the little margins. I have an x and I have a 2, and basically that means each one needs what the other fraction has. So I'm going to multiply 2 and 2 and x. That's going to give me 6 plus x squared over the common denominator of 2x. And I'm going to change my division to be multiplication, and I'm going to flip my second fraction. So I'm kind of already down here at step 3. I rewrote in red. I added or subtracted in this orange first step. Keep, change, flip my second fraction. Now I'm going to figure out what my undefined values are. And remember, with division, we're not only checking both denominators, we are checking the divided numerator. So x cannot equal 0, x cannot equal 1, and from here, I would also get x cannot equal 0. Now that I have turned this into a multiplication problem, that is our favorite. All we have to do is numerator times numerator, denominator times denominator. That is going to give me x times x squared plus 6 all over 2x times x minus 1. I'm going to distribute this x out to be x cubed plus 6x all over 2x, x minus 1. Now, one thing that we could do further is if I had left it in this original form, which I think I would accept this as a final answer, you could go in and you could cancel out 1x and another x and end up with x squared plus 6 all over x times x minus 1 as well. Now, with number 7, I'm going to go through the same steps. First, I'm going to rewrite because I don't like looking at it in this way. 3 over x minus 4 divided by 1 minus 2 over x minus 4. Now, remember, anytime you have the number 1, it could be anything. You can turn it into anything that you want or you need. I want it to have a denominator of x minus 4. So I'm going to rewrite it so that it is x minus 4 over x minus 4. Going to simplify my life a whole lot easier. And I'm going to get 3 over x minus 4 divided by x minus 4 minus 2 is x minus 6 divided by x minus 4. Now this problem looks so much easier and more manageable than this problem. That is why my first step is to always rewrite. Now I'm going to keep, change, flip. Keep the first fraction exactly as it is, change it to multiplication, flip the second fraction. I'm going to get my undefined values. X cannot equal 4, x cannot equal 6, and with a little bit of cancellation, this x minus 4 and this x minus 4 cancel each other out because they are being multiplied. I end up with 3 over x minus 6. Now, number 8 is a doozy. It's a tough one. There's a lot going on, but don't worry. We're going to get through it. First thing I'm going to do is rewrite. 1 over, and I went ahead and took out this GCF in this step just to kind of make the process a little bit smoother. 3 times x squared minus 1, which, that should already be a little red flag. This needs to be factored more. Divided by 5 over x plus 1 minus x plus 4 over, and I went ahead and factored this denominator 2 to be x minus 4, x plus 1. Second step is going to be multiplying. So I'm going to see that both of these have an x plus 1 in common. First fraction is missing an x minus 4. So I need to give this fraction over here, 5 over x plus 1, a x minus 4 in the top and an x minus 4 in the bottom in order to create a common denominator. So let's go ahead, jump a step. 1 over 3, x plus 1, x minus 1. Remember, we talked about how this needed to be factored more. Divided by 5 times x minus 4 minus x plus 4. Don't forget, this negative is going to distribute to both terms all over my common denominator of x plus 1, x minus 4. Now, this numerator is going to simplify to be 5x minus 20 minus x minus 4. When I combine all of those like terms, I'm going to end up with 4x minus 24. So that's my denominator that's getting replaced here. So I'm going to go through these steps of keep, change, flip. Keeping my first fraction exactly as it is, changing it to multiplication, flipping my second fraction. So my denominator of x plus 1, x minus 4 is now my numerator, and my numerator of 4x minus 24 is now my denominator. We're almost there. Going to get my undefined values. Remember, it is everything not equal to 0. One thing I did do is for this problem, I pulled out my 4. For this denominator, 4x and 24 have a GCF of 4. So I pulled it out just so it was easier to see what the undefined value is. So from all of this, I get x cannot equal plus or minus 1, x cannot equal 4, and x cannot equal 6. And from here, it's just cancellation. Cancel out whatever you have a pair of in the top and in the bottom. So I do have some x plus 1s that match. I do have I think that might be it. I have an x minus 4. I think that is currently all we can cancel out. So it gets a little bit more difficult, but that's fine. I end up with only having an x minus 4 in my numerator. And then I have 3 times 4, which is going to make my 12. And then I'm left with an x minus 1 and an x minus 6. So my final answer ends up being x minus 4 over 12 times x minus 1, x minus 6.